Welcome back to Beyond the Unknown, the place we go to explore the edges of what's possible. I'm Alex Carter,
And I'm Olivia Reyes.
and today we're taking you on a deep dive into a pivotal moment in AI history.
Really a fascinating one.
It's episode 19,
Oh, wow.
DeepMind AlphaGo, the first AI to beat the pros. Our primary source is the report, and let me tell you, this report is packed with fascinating details.
Oh, it is. We're talking about DeepMind's AlphaGo, an AI that didn't just play the ancient game of Go, it mastered it
Mastered it.
in a way that shocked the world.
Yeah, and we're not talking about some simple game here. Go has long been considered a grand challenge for AI. It's a game of incredible complexity with more possible board positions than there are atoms in the universe.
Exactly. Traditional AI approaches relying on brute force calculations simply couldn't crack the code of Go. It required a different kind of intelligence, one that could handle the game's nuanced strategies and intuitive leaps.
And that's precisely what DeepMind achieved with AlphaGo. They combined a few powerful techniques to create an AI that could not only play Go, but actually learn and adapt in ways that were previously thought to be exclusively human.
One of the key breakthroughs was the use of supervised learning and reinforcement learning in tandem. Think of it as a two-stage process.
Okay, I'm intrigued. Break it down for us what happens in each stage.
In the first stage, supervised learning, AlphaGo is trained on a massive database of human-played Go games. It's like learning the basics from the masters, studying their moves, and absorbing the fundamental principles of the game.
So it's like giving the AI a crash course in Go strategy, showing it the ropes before letting it loose on its own.
Exactly. But here's where things get really interesting. The real magic happened in the second stage, reinforcement learning. This is where AlphaGo started playing millions of games against itself, refining its strategies through trial and error.
So it became its own teacher, essentially, learning by doing on a scale that no human could ever match.
Precisely. And through this process of self-play, AlphaGo was able to discover strategies and make moves that had never been seen before in the thousands of years that humans have been playing Go.
Now I'm imagining all those potential moves in Go, the sheer vastness of the possibilities.
Yeah.
How did AlphaGo manage to navigate that complexity without getting bogged down?
That's where another key innovation comes in, Monte Carlo tree search, or MCTS. It's a method that allows the AI to simulate the outcomes of various moves, essentially looking ahead to evaluate the best path forward.
So instead of analyzing every single possible move, which would be impossible even for a supercomputer, AlphaGo uses MCTS to efficiently explore the most promising lines of play.
Exactly. It's like a chess player thinking a few moves ahead, but on a much grander scale and with a level of computational power that we can barely comprehend.
But there's more to it than just brute force calculation and strategic planning, right?
Yeah.
I remember reading something about AlphaGo utilizing neural networks almost like a brain within the machine.
You're absolutely right. AlphaGo uses two neural networks, the policy network and the value network, working in harmony to guide its decision-making.
Okay, let's unpack that. What do these networks actually do? They sound pretty important.
Think of the policy network as the intuitive part of AlphaGo's brain. It's responsible for suggesting the most promising moves in a given situation.
So it's like AlphaGo's gut feeling honed through millions of self-played games.
Exactly. And then we have the value network. This network is more like the strategic advisor constantly assessing the board position and calculating the probability of winning from that position.
So it's not just about making flashy moves. It's about understanding the long-term consequences of each decision. It's like having a grandmaster whispering in your ear saying, this move might look good now, but it'll cost you the game down the line.
That's a great analogy. And this partnership between the policy network and the value network, along with the power of reinforcement learning and MCIS, allowed AlphaGo to achieve a level of mastery in Go that was simply unprecedented.
So we've got this incredibly sophisticated AI that's mastered Go through self-play and strategic innovation. What happens next? Time to put it to the ultimate test, right?
Absolutely. And what a test it was. In March of 2016, AlphaGo faced off against Lee Sedol, a legendary Go player widely regarded as one of the best in the world.
This was a highly publicized event, a 5-game match that captured the world's attention. It was like the ultimate showdown, man versus machine. I remember following it closely, and the tension was palpable.
Right.
What was the outcome? Refresh my memory.
Well, let's just say it sent shockwaves through the world of Go and beyond. AlphaGo defeated Lee Sedol 4-1. A decisive victory that signaled a paradigm shift in the world of artificial intelligence.
Wow, that's an incredible feat. Do you remember anything specific about those games? Any moments that really stand out?
Oh, absolutely. There's one move in particular that became legendary, move 37 in Game 2. It was a move so unorthodox, so brilliant, that it stunned not only Lee Sedol, but Go experts around the globe.
I vaguely remember hearing about this. What was so special about this move? Why did it cause such a stir?
Well, it demonstrated that AlphaGo wasn't just mimicking human strategies or relying on brute force calculation. It was coming up with genuinely innovative approaches, pushing the boundaries of what was considered possible in Go.
So it was playing creatively, almost like it had its own unique style.
You could say that. It was evidence that AI could do more than just follow rules. It could think outside the box, or in this case, outside the board, and come up with moves that had never been seen before.
That's mind-blowing. And this wasn't just some casual game. It was a high-stakes match against one of the best Go players in the world, broadcast to a global audience. Talk about a statement?
It was a defining moment, a turning point in our understanding of what AI could achieve. AlphaGo's victory wasn't just about a game, it captured the world's imagination. It showed everyone the sheer power and potential of AI, and it sparked a wave of excitement, but also some apprehension about what the future might hold.
I can imagine seeing a machine outperform a human at such a complex and intuitive game definitely raises some profound questions about the nature of intelligence and the role of AI in our world.
It certainly does. And those are questions that we'll continue to explore as we delve deeper into the legacy of AlphaGo and its lasting impact on the field of AI.
This is already so fascinating, and we're just getting started.
It really makes you think about, where AI is headed and how quickly it's developing.
It really does.
Yeah.
So, we touched on AlphaGo Zero earlier, the version that learned Go entirely from scratch.
Oh, yeah.
But that wasn't the end of the story.
It wasn't.
So tell me a little bit more about that. What happened after AlphaGo Zero?
So they took those core principles, especially the reinforcement learning and the self-play, and they created something even more remarkable called AlphaZero.
Wait, AlphaGo Zero and AlphaZero. I feel like AI naming schemes are designed to confuse podcast hosts.
It is a little bit confusing.
It is, yeah.
But think of it this way. AlphaGo Zero was the specialist, like the ultimate Go master, right? But it was still confined to that specific domain. AlphaZero, on the other hand, was designed to be a generalist.
Okay, so AlphaGo Zero is like the grandmaster that dedicated their life to mastering Go. But AlphaZero was more like a prodigy who could pick up any game and excel at it.
That's a great analogy. AlphaZero wasn't pre-programmed with any game-specific knowledge. It started with just the basic rules of a game, whether it was Go chess or shogi, and then it was set loose to learn through self-play.
So it's like they gave AlphaZero a blank slate and said, figure it out.
Exactly, and figure it out it did. Within hours, AlphaZero surpassed human-level performance in not just Go, but also chess and shogi.
Hold on. So it learned 3 complex strategy games, all at a superhuman level, just by playing against itself.
That's right.
That's incredible.
That's the power of reinforcement learning and self-play. By removing the constraints of human data and pre-programmed knowledge, AlphaZero was able to explore the possibilities of these games in a way that humans simply couldn't. It's like it unlocked a whole new level of strategic thinking.
This is starting to sound like the plot of a sci-fi movie, where the AI becomes too smart for its own good. Should we be worried?
Well, let's not jump to conclusions just yet. AlphaZero's achievements are certainly impressive, but it's important to remember that we're still in the early stages of AI development.
Okay, fair enough.
Yeah.
But it does raise some fascinating questions about the nature of intelligence and the future of AI. If a machine can master multiple complex games just by playing against itself, what else is it capable of learning?
That is the million-dollar question. And while we can't predict the future with certainty, we can explore some of the potential implications of AlphaGo's legacy and the advancements it has spurred in the field of AI.
That sounds like a great place to focus our attention. We've talked about the technical marvels of AlphaGo and its successors, but what about the practical applications? How is all of this actually being used in the real world?
That's a crucial question, and the answer is in many ways. Remember, AlphaGo's impact wasn't limited to the world of games. The techniques developed by DeepMind, particularly reinforcement learning and neural networks, have found applications in a wide range of fields.
Give us some concrete examples. How is this technology actually being used to solve real-world problems?
Let's start with healthcare. Imagine AI systems that can analyze medical images, diagnose diseases earlier and more accurately, and even personalize treatment plans based on individual patient data.
So AI doctors. That sounds both promising and a little intimidating.
It's definitely an area that requires careful consideration and ethical oversight, but the potential benefits are enormous at times. AI could assist doctors in making faster and more informed decisions, leading to better patient outcomes and potentially even saving lives.
Okay, that's healthcare. What about other fields? Where else are we seeing these AI advancements make a real difference?
Materials science is another exciting area. Researchers are using AI to discover and design new materials with specific properties. Imagine lighter and stronger materials for aerospace or more efficient solar panels that can revolutionize renewable energy.
So AI could be key to tackling some of the world's biggest challenges like climate change and resource scarcity.
Absolutely. And the applications go even further. We're seeing AI being used in robotics, finance, transportation, logistics, and countless other industries.
It's like AlphaGo opened a door to a whole new world of AI-powered solutions. It's both exhilarating and a bit overwhelming to think about the possibilities.
I completely agree. AlphaGo's legacy extends far beyond the game of Go. It's a testament to the power of human ingenuity and the transformative potential of artificial intelligence.
So where do you think this is all headed? What's the next frontier for AI, especially in light of what we've learned from AlphaGo and its descendants?
Well, one area that's generating a lot of buzz is the development of even more general-purpose AI systems. AlphaZero was a step in that direction, but it still required some basic rules as a starting point. The ultimate goal is to create an AI that can learn anything regardless of the domain or task.
Wow, that sounds incredibly ambitious. An AI that can truly learn and adapt to any situation. Is that even possible?
It's a grand challenge, no doubt, but it's a goal that many researchers are striving towards, and if we can achieve it, the implications are profound.
I can only imagine. But what about the ethical implications? As AI becomes more powerful and more general purpose, don't the risks increase as well?
You raise a crucial point. As we continue to push the boundaries of AI, it's essential to consider the potential risks and challenges alongside the potential benefits.
So it's a balancing act, embracing the possibilities while being mindful of the potential downsides.
Exactly. And that's why open and honest conversations about the future of AI are so important. We need to engage with these questions as a society and develop ethical guidelines and regulatory frameworks to ensure that AI is used for good and that its development aligns with human values.
Now, we've covered a lot of ground today, from the technical details of AlphaGo to its broader impact on AI research and the ethical questions it raises. But I want to circle back to something you said earlier about creativity.
Yes.
Yeah.
The question of whether AI can truly be creative, a question that AlphaGo's innovative gameplay brought to the forefront.
Exactly. We've seen AI systems like AlphaGo come up with novel solutions that even the most experienced human experts find surprising. But is that true creativity, or is it just sophisticated pattern recognition?
It's a debate that continues to fascinate and challenge us. But I think it's important to remember that our understanding of creativity itself is constantly evolving.
So what we consider creative today might seem quite ordinary in the future as AI systems continue to push the boundaries.
Precisely. And who knows, maybe AI will eventually surpass human creativity in ways that we can't even imagine right now.
It's a mind-boggling thought. But before we get too carried away with speculations about the future, let's take a moment to appreciate just how far AI has come in a relatively short period of time.
I agree. AlphaGo was a monumental achievement, a testament to the ingenuity and dedication of the researchers at DeepMind.
And it's a reminder that we're living in an age of extraordinary technological advancement, where the line between science fiction and reality is becoming increasingly blurred.
Well said. And as we continue to explore the frontiers of AI, it's vital to approach this journey with a sense of wonder and a commitment to responsible development.
And for our listeners out there, if you're as captivated by the world of AI as we are, be sure to check out our previous episodes on the topic. We had some insightful discussions about ChatGPT back in episodes 2 and 4, and our deep dive into AlphaFold and protein folding in episode 17 is definitely worth revisiting.
Those are great starting points for anyone who wants to explore the diverse applications of AI and its impact on various fields.
Now, before we wrap up our deep dive into DeepMind and AlphaGo, I want to leave our listeners with a final thought to ponder. We've marveled at AlphaGo's mastery of Go, its evolution into a more general-purpose AI with AlphaZero, and the potential of these technologies to revolutionize everything from healthcare to material science.
It's really been quite a journey, huh? Exploring the capabilities of these remarkable AI systems and the implications for our world.
But here's a question that keeps nagging at me. Despite all these advancements, can AI ever truly understand the game it's playing or the problem it's solving? Or is it simply a master of manipulating symbols and patterns without any genuine comprehension?
That's a profound question, and one that really gets to the heart of what we mean by intelligence and understanding. We've seen AI systems exhibit behaviors that we might interpret as understanding or even consciousness, but can we ever truly know what's going on inside these complex algorithms?
It's like peering into a black box. We see the inputs and the outputs, but the inner workings remain a mystery.
Exactly. And this raises all sorts of questions about the nature of intelligence, consciousness, and even the meaning of understanding itself. It's a philosophical rabbit hole that we could explore for hours.
And maybe we will in a future episode.
Yeah.
But for now, I think it's okay to embrace the mystery, to acknowledge that we're still in the early stages of understanding AI in its full potential.
I agree. The journey of discovery is just beginning, and who knows what amazing breakthroughs and thought-provoking challenges await us in the future.
Well said. And to all our listeners out there, we encourage you to keep those questions in mind as you continue to follow the evolution of AI. It's a field that's full of surprises, and we can't wait to see what the future holds.
Until next time, keep exploring and keep questioning.
This is Alex Carter,
And Olivia Reyes.
signing off from Beyond the Unknown.